Welcome everyone. This is Mahinder Taniru. Today, this presentation is on database normal forms. So, normalization is one of the important concepts in database design because it helps us structure data efficiently, remove duplication, and ensure data consistency. In this presentation, I will explain all the key normal forms and demonstrate how to fix the normalization issue in the assignment table involving the lab result. So you can see the slide. So today we'll be covering the topics on database, what is database normalization and why it is important. And we also going to discuss the normal forms like 1F, 2F, 3NF, and BCNF. And we'll be also going through an example of a lab result table and the solution for the violation. So for this slide, it gives an overview of what we'll cover. First, I'll explain what normalization is and why it is necessary in the databases. Then we'll go through the different uh, forms starting from 1F to BNF. Finally, we'll look at the assignment table. So normalization is the process of the structuring data to reduce some redundancies and improve consistency. So normalization improves the database efficiency by organizing the data logically. It avoids duplication and maintains the data integrity. So coming for this slide, the first normal form or 1F is the basic foundation for all the other normal forms. According to 1F, every value stored in the table must be atomic. That means one cell should hold only one value, not multiple values. Additionally, there should be no repeating groups such as the column like lab result 1 and lab result 2. If a table breaks these rules, it's not in the proper one and F and needs restructuring. So from the assignment, we can see that the assignment table values the 1F mainly because it contains the repeated column for the lab results. Like lab 1 result and lab result 2 represent the same type of information. Like these are multiple lab results, but they're stored in the separate columns. This is a classic example of an repeating group. Because of this, the data is not atomic and becomes harder to query, update, and expand. So the table must be restructured into a more normalized format. So coming to the second normal form, so this builds on the 1NF and deals with something called partial dependency. So 2NF is only relevant when the primary key is composed. So which means that the key is made up of two or more columns. If 2NF, every non-key attribute must depend on the whole primary key, not just the part of it. This prevents the redundancy and ensures that all information relates properly to the key. So coming to the 3NF, which is the third normal form, it focuses on removing the transitive dependencies. A transitive dependencies happen when a non-key attribute depends on another non-key attribute instead of directly depending on the primary key. To satisfy the 3NF, every non-key attribute must depend on the primary key. This eliminates the hidden relationship between columns and results in a cleaner, more efficient table structure. So coming to the BCNF or the buoyancy chord normal form is a stronger version of 3NF. While 3NF handles the most dependency issues, BCNF adds an extra rule, like every determinant in the table must be a candidate key. From this prevents more complex anomalies that may still occur even when a table is 3NF. BCNF ensures that every attribute is fully and uniquely determined by a proper key. So from this slide, we can see that the table contains such as lab code, patient ID, lab result 1 and lab result 2. The problem here is the lab results are stored in the separate columns instead of the separate rows. This is not only violating one NF but also make the structure inflexible. For example, what if a patient has a third or fourth lab result? This design doesn't work on the scale. So to fix this violation, we need to redesign the table so that each lab result is stored as a separate record. We created a new table which represent a row, one lab result for a patient. This new structure removes the repeating columns, making all values atomic and follows the principles of normalization. By doing this, we achieve a proper 1F and prepare the table to satisfy the higher normal forms. So from this slide, we can also see the finalized normalized version of the table. Now, instead of storing the multiple lab results in the different columns, each lab result is stored as its own row with a result number and a value. This format is much cleaner, easier to manage, and also eliminate redundancy. The table now satisfies 1F, 2NF, and 3NF because all dependencies are properly organized. To summarize, normalization is essential for designing professional, scalable, and reliable databases. The 1F, the 1NF ensures the atomic values, 2NF removes the partial dependencies, and 3NF removes the transitive dependencies. So in the assignment, the main issue was the repeating lab result columns, which were resolved by the restructuring of the table into a row-based format. This makes the database more consistent and also easier to query. So that concludes the presentation. If you have any more questions about the normal forms or the how assignment is solved, feel free to ask. I'm happy to explain any part of normalization processes or to provide any additional examples if needed. Thank you.